Often, we want our programs to define or to behave in different ways depending on the state of some variable or some kind of input. In this continuation on the lecture about Python programming fundamentals, we'll be talking about conditional statements. Conditionals always take the form of if, then. This is for some reason not rendering correctly, but this should be italicized. So in formal logic, we might make an expression like if P, then Q. Only if P is true does Q happen, or is Q also true. We're very familiar with these kinds of statements in regular language, and the way they behave in formal logic or in programming is pretty similar. Let's examine a simple function that prints out a high score based on whether or not a player's score exceeds the high score. We'll express this if-then statement in code by saying if player score is greater than high score, and then we'll have code that performs a task if this condition is true. This is a conditional statement or a comparison. Earlier we saw a comparison for cube 3 equals 27. We could also have a comparison like cube 3 greater than 5. Here we have two arguments of a function, and we're testing if one argument is larger than the other argument. Notice these comparisons, evaluated to Boolean values. A conditional is the combination of an if statement with some Boolean expression. So this comparison is a Boolean expression because it returns a Boolean value. So, if this Boolean expression is true, then we print high score, and we set high score equal to player score. Then, at the end, we return the high score. There's an implied decision here, where if the player score is less than the high score, then the high score doesn't get updated to the player score. We simply return the original high score. Here we also notice the body of this conditional statement is indented, or the body of this if statement is indented. Again, Python uses whitespace to signify a context. Within the context of this if statement, we will do these things. So if, in the context in which this condition is true, we'll perform the following actions. Outside of that context, meaning regardless of whether it's true or not, we will do this action. And all of this is within the context of the test high score function. Now that this function is defined, let's try it out and make sure it works. So, if a player scores 83 while the high score is 98, we should see a high score of 98. And we do. However, if a player scores 95 and the current high score is 93, the high score should update to 95, and additionally, we should be alerted that we scored a new high score. So the function now prints out high score and updates the high score to 95. Often when we're considering conditional statements, it may be useful to create a flowchart to illustrate what might happen under different conditions. We test the condition whether the player score is higher than the high score. If it is, then we do these things. If it's not, then we don't do anything. In either case, at the end, we return the high score. These kinds of diagrams become especially useful when we nest conditional statements to make more complex decision trees. Here we have an example of nested if statements. Our nested example will accept some argument x. If x is less than 50, we check if it's even. If it's even, then we return the string branch A. Otherwise, we return branch B. If x is greater than 50, then we return branch C. The first argument that we pass to nested example is 42, which is less than 50 and even. So this should print out branch A. 51 is greater than 50. So this line should print out branch C. 37 is less than 50, but it's not even. So it will return branch B. And indeed, 42 returns branch A, 51 returns branch C, and 37 returns branch B. Again, we might want to make a flowchart to consider the different possibilities of each of these conditional statements. The first thing we test is if x is less than 50. If it is, we have an additional test of whether x is even. To test if x is even, we use this special percent sign operator. This corresponds with what's called the modulus in mathematics. Modulus is simply dividing one number by another and then returning the remainder. For instance, 5 modulus 2 would be 1, because 5 divided by 2 has a remainder of 1. 5 modulus 3 would be 2, because 5 divided by 3 has a remainder 2. So by dividing x by 2 and checking if the remainder is 0, we can tell whether or not x is even. As I mentioned before, comparisons are expressions that evaluate to Boolean values. We can combine different operations, such as addition, with comparisons. And we can essentially make a Boolean expression out of arbitrarily complex Python expressions. Here we have 3 different Boolean expressions. One comparing if 50 is greater than 10, one comparing if 2 plus 2 is equal to 4, and one comparing if negative 3 is greater than 2. We see the associated outputs that we'd expect. Boolean expressions can also be combined using logical operators. If you're familiar with formal logic, you might be familiar with the logical operators and, or, and not. And or are operators for combining Boolean expressions. Not is the negation of a Boolean. In order for condition A and condition B to be true, both condition A and condition B must be true. If either one is false, then condition A and condition B is false. This is in contrast to condition A or condition B. Condition A or condition B is true when either one is true. So when condition A is true, but condition B is false, condition A or B is still true. Here, this truth table shows how these conditions combine under the and or operations. But of course, essentially, the and or operations operate exactly as they do in plain spoken language. Here, we illustrate in code the and or operations at work. True and true is true. True and false is false. The remaining statements are also false, as illustrated in our table above. So we have true followed by 3 falses. True or true is true. True or false is also true. False or true is true. But false or false is false. So we have 3 trues followed by a false. As mentioned before, we can combine arbitrary Python expressions to make more complex Boolean expressions. Here we have 2 variables, x and y. We'll have Boolean expressions comparing the variables to various numbers, and then we combine the Boolean expressions using logical operators. So x greater than 4 and y greater than 2, both of those are true, so this evaluates to true. X greater than 7 and y greater than 2 evaluates to false, because x is not greater than 7. However, x greater than 7 or y greater than true evaluates to true, because y is greater than true. We can additionally negate Boolean expressions. Not true is, of course, false. Not false is, of course, true. These logical operations are analogous to addition, subtraction, multiplication, what we would call arithmetic operations. They operate differently because they work with different kinds of objects. They work with true and false values instead of numbers. But they have a similar kind of idea behind them. Here, we begin combining logical operations into still more complex Boolean expressions. I'll leave it to you to evaluate that these return the correct things. I'd like for you to pause the video here and complete the following exercises. Now that we know how to write functions and perform conditional checks to direct what happens in a function, write a function which accepts a number as an argument and returns true if it's greater than 10 but less than 20, or if it's less than negative 100. Secondly, in your own words, explain what the percent operator does. Pause the video now and complete these exercises. Then I'll share my solutions. Okay, so for exercise 1, we'll create a new function called exercise1, which accepts a number as an argument. We'll just say n for short. If n is greater than 10 and n is less than 20, or n is less than negative 100, we'll return true. Otherwise, we'll return false. Notice I've introduced a couple of new ideas here. First of all, I used parentheses to indicate a grouping of Boolean expressions. I will first evaluate these together into one true or false value before considering its combination with this other Boolean expression. Another trick here is I don't have an else statement, but I just have a return false. This is equivalent to if I had else return false. The reason why is because if the condition is satisfied, then I return true, and the execution of the function halts, so nothing happens afterwards. Therefore, by default, anything that comes after this is effectively only going to execute if this is not true. So it's sort of automatically in an else statement, because within the body of the conditional statement, we have a return statement. Let's test out this function to make sure it does what we think. So, -101 returns true. 30 returns false. 5 also returns false. But 11 returns true. So this function does what we want. You can refer back earlier in the video for my explanation of the modulo operator. I'm going to halt this video here, and in the next video we'll talk about iteration.